Hi everybody, today what I wanted to go through is just linear approximation, because I know a lot of people don't actually understand what this is and they have a hard time in actually knowing what it is, linear approximation. So first of all, I thought we might go through exactly how we obtain the formula, even though some of you may not care. We'll still try, okay? So if you remember back from when we were doing differentiation and we were using first principles, okay, we said that the gradient was equal to fx plus h, which was that little bit that we moved by in the y direction, take away so y2 take away y1 over x2 take away x1, which will just give you h. Okay, and then we had a lim in front, right? A limit telling you that h has to approach 0. Now what we do is to obtain the linear approximation equation, we basically take this h and we move it over there. So it becomes hf dash x equals to fx plus h take away fx. So finally, if we rearrange it one more time, what we'll get is what is known as the linear approximation formula, which says that this value here, which was obtained by adding in a value of h, is going to be approximately equal to just your normal y value, which turns into positive because I'm going to move it on the other side, so that turns the sign in front turns positive, plus hf dash x. So this is known and referred to as your linear approximation formula. Okay, so that's what the formula is, and that's how we obtain it. Now the next thing to understand is basically, why on earth do we use this formula? What purpose does it serve? Well, for instance, linear approximation is used when you want to figure out an approximate answer for some problem and you don't have your calculator with you. So say you want to figure out the answer to square root of 103, for instance. What you can do is you can use linear approximation for this problem and figure out the answer. And you have to remember that if you have a problem like this on your exam and it asks you to use linear approximation, then you can't just plug that in your calculator, write the answer down, because you'll get 0 for your marks. Okay, so let's have a look at how we do this linear approximation. Basically, if I just rewrite this formula again and explain a few things about the formula, so that's an approximation sign, equals to your y value plus a little bit of h times yf dash x. As you can see, this part here is basically the summation of an x value and this h value. Now h, as you remember, has to be quite small for this linear approximation to be a good one. So basically what we need to do in linear approximation, the way I always remember this, is the first method is to set up a formula, set up a function, okay, and the second thing is to derive the function, because you're going to need to derive a function here to use it for that. Derive a function. And then the third thing is you have to identify an appropriate value for h. Identify a value of h. So as long as you use these three particular steps, you should be able to get the answer. So let's try to do this for this problem here, for this square root of 103. Let's have a go. Now, if we have to set up a function is y in terms of x, okay? So if we have to do that, then the way I always remember is I look at my problem and I kick out the number in that problem. So I would kick out the 103 and just put an x there. Okay, so my function for this particular problem will just be square root of x. So I kick out 103 and just place x, and then I can make up my function. So this becomes my function of fx, okay? So that we have done number one. Number one is complete. Now, we need to derive this function, because if you remember in your linear approximation problem, you need to have the derivative of the function. So let us look at how we derive it. First of all, I'm just going to write out what this actually is in indices. So this x is actually to the power of a half. So it's x to the power of a half like that. And after we've done that, we're going to derive it. So I'm just going to put it here. The derivative of fx is equal to, you bring the power down, so it becomes half, and you reduce the power by 1. So as you can remember, half take away 1 will give you minus half. Okay? And I'm going to get rid of this because the mess is going to annoy me. But here we have set up our derive the function. We have derived the function over there. And of course we can beautify this by moving that to the bottom. Just the x, okay? So the x can be located with the 2 at the bottom. And then we need to identify an appropriate value of h. So what we basically do, the way I always remember this, is I know what I'm trying to do is I'm trying to find an answer for f x plus h is going to be equal to f x plus h f dash x. Okay, so what I'm doing in linear approximation is I'm looking at 103 and I need to solve that. I need to get an answer for it without using a calculator. So what I'm going to do is I'm going to find a method to split that 103 down into 2 parts. One will be x and one will be h, okay? So I'm going to split up 103 into x and h. Now the smartest value of x to choose, because you're ultimately here, as you can see, you're ultimately going to have to go f of x. So if you look back to the function f of x, you need to choose a number for x that you can actually square root. Otherwise, you need a calculator, right? And the whole purpose of this is not to use a calculator. So what we're going to do is I'm going to split this up into my x. I'm going to choose to do 100 because I can actually put 100 into the square root and solve it, and it will give me 10. All right? And if I make it 100, I have to have 103, so I have to make my h value 3. And so now I've split it up into x and h, and then I just plug everything in. So I go f of x, which I made 100, remember, so it's going to be f of 100 plus h, which is 3. And then I'm going to, into my derivative, place in 100 as well. Okay, so far we've got an expression here that will probably help us figure out the actual answer to this, which is the goal, which is the purpose, okay? So let's have a look at how we would actually do this. So 103, now I can write, f of 103 is equal to approximately. Now, f of 100 comes from here, f of x. If this is now 100, then you have to just replace everywhere where you see x with 100. So it's going to be square root of 100, okay? And then you're going to add 3 times by, into the derivative this time, you have to put in 100. So I'm going to beautify that before I do this. Just going to simplify it a little bit more so it can be easier to substitute in. So I'm going to do what I said before, that carry this to the bottom. So 2 times x to the power of a half, which is square root of x. And now I can just, this becomes my derivative.